Hey all! Today we'll be assembling our Avid CNC rotary axis. The Avid CNC rotary axis adds rotary cutting and indexing capabilities to Pro CNC and benchtop CNC machines. This kit includes a self-centering 4-jaw chuck, adjustable length tailstock, independent framework, and profile linear guide rails to allow quick and easy workpiece setup. If you haven't already, check out our helpful listing and site with step-by-step instructions with tips, tricks, and detailed diagrams. This will walk you through the assembly, installation, and calibration processes. Okay, on to the frame assembly. This example is for a recessed rotary. A table-mounted rotary will have small variations which will be indicated in the written instructions. First, we'll prepare our 272mm 40/80 extrusion. Thread a socket head cap screw into the T-nut through the anchor fasteners. We'll slide the anchor assemblies onto the 40/80 extrusion, and then repeat this process at each corner of the extrusion. Next, we'll slide the 40/80 extrusion assembly onto the 40/40 frame extrusion pieces. The lengths will vary depending on your rotary configuration. They are the two long pieces. Then we'll take our short 40/40 extrusions and insert the socket head cap screws through the anchor fasteners into the extrusion slots. We'll partially thread on the fasteners into the double T-nuts. Then we'll slide a 40/40 extrusion assembly into the rotary frame on each end. We'll position the 40/40 extrusion flush with the ends of the rotary frame and then fully tighten the 40/40 extrusion assembly fasteners. We'll position the 40/80 extrusion assembly 120mm or 4 3/4 inches from the end of the rotary frame. Then we'll partially tighten the 40/80 extrusion assembly anchor fasteners. By following the diagram, we'll insert our roll-in T-nuts to attach the chuck plate. Then use the holes on the chuck plate and a small Allen key to line up the T-nuts to the holes. We'll attach the chuck plate to the 40/80 extrusion and partially tighten the fasteners. Note the orientation of the chuck plate with the dowel pins toward the closer end of the rotary frame. Next, we'll partially thread the fasteners and sliding T-nuts onto the linear rails. This is a little tip we picked up from Frank Howarth. To suspend your rail over the frame, drop in the fasteners, and line up the sliding T-nuts for quicker assembly. Slide one of the linear rails onto the frame extrusion and offset it 1 inch from the non-chuck end of the rotary frame. Then we'll assemble our rail alignment jigs and mount one to each end of the frame next to the linear rail. And fully tighten those fasteners. Then find those perfect small clamps and clamp down the linear rails to the jigs. Then fully tighten the fasteners while clamped. Next, we'll use a framing square to align the back of the dowel pins on the chuck plate to the installed linear rail. Then fully tighten the fasteners on the chuck plate. You might find it easier to hold the framing square to the inside or the outside of the linear rail. Either is fine, just be sure that it's square. Then we'll fully tighten the four 40-80 extrusion anchor fasteners. We'll install the bottom chuck clamp. Orient it with the small holes facing forward and position the chuck clamp flush against the dowel pins. Ensure you use the M8 16mm socket head cap screws. These will be located in a separate bag, and fully tighten these fasteners. Orient the reducer with one of the access holes facing up, and with the reducer flush against the bottom chuck clamp. Align the holes shown in the reducer with the holes in the front of the bottom chuck clamp and fasten it in place. Next, we'll attach the top of the clamp and tighten the fasteners incrementally. We'll attach the M5 shoulder bolt to the adapter plate. Align the dowel pin in the reducer with the hole shown in the adapter plate. We'll tighten the fasteners incrementally, alternating between fasteners. Now we can slide on the chuck. Be careful, as this is one of the heavier parts and will be slightly oily out of the package. Be sure to align one of the jaws with the shoulder bolt on the adapter plate. This is important for the A-access sensor later on. Use the 6mm stubby Allen wrench included in your rotary kit to tighten. We'll remove the hole cover and insert the 4mm Allen wrench through the reducer access hole into the shaft collar. We'll remove the motor key on our NEMA 34 motor. Then attach the motor to the reducer. The motor can be mounted in any orientation. Just be mindful of how you'd like the direction of your cable to be, depending on your rotary axis mounting orientation. Be sure to fully tighten the shaft collar using the 4mm Allen wrench. Now onto the tailstock assembly. We'll slide the second linear rail onto the extrusion. Install the grease fittings into the linear bearing blocks. Do not remove the plastic bearing retainers at this time. Next, we'll slide the linear bearing blocks onto each rail. Use the rail to push the plastic retainer out of the block. Orient the blocks with the grease fittings facing toward the chuck. Attach the spring plungers to the tailstock plate. Fully thread on the spring plungers into the tailstock plate and tighten the jam nuts with the wrench. Set the tailstock body on the tailstock plate and orient the tailstock with the live end facing away from the spring plungers. Insert the dowel pin and fasten the tailstock to the tailstock plate. Attach the tailstock assembly to the bearing blocks and partially tighten the fasteners. Turn the tailstock handle counterclockwise to remove the live center. And extend the tailstock 65 mm or 2.5 inches. Then lock the tailstock. If you're completing a recess-mounted frame assembly, then you can insert the tailstock all the way into the chuck. If you're following a table-mounted assembly procedure, only insert it 1 inch into the chuck. And then tighten the chuck. With the tailstock clamped in the chuck, then tighten the tailstock plate fasteners. We'll remove the tailstock from the chuck. Rotate the spring plunger handles to lock the tailstock in place. The spring plungers will lock into the counterbores on the linear rails. You may need to adjust the position of the second linear rail for both spring plungers to lock in place. With the tailstock locked in place, tighten the indicated fasteners on the second linear rail. Unlock the spring plungers and tighten the remaining linear rail fasteners while moving the tailstock down the rail. Now onto the chuck alignment. Insert the drill center into the chuck and tighten the chuck with the drill center flush against the jaws. Then position the tailstock next to the chuck. We'll use the alignment procedure in the following steps to align the tip of the drill center with the tip of the tailstock's live center. Either the front or rear jack screw locations will be used, depending on which way the chuck needs to be adjusted. The front jack screw locations will adjust the front of the chuck up, and the rear jack screw locations will adjust the front of the chuck down. If the rear jack screw locations are to be used, loosen only the indicated fasteners. Insert the jack screws and jam nuts into the front or rear locations. Tighten both jack screws the same amount to raise or lower the chuck so the drill center lines up with the tailstock. Then tighten the 2 jam nuts. Tighten the fasteners that were loosened in the previous steps. Then we'll attach the touch plate isolator to the tailstock plate. We'll attach the sensor bracket to the bottom chuck clamp, and then insert the proximity sensor. We'll rotate the chuck to align the shoulder bolt with the sensor. Thread the sensor in until it touches the shoulder bolt, and back the sensor out 1 full turn, then tighten the sensor jam nut. Your rotary is now ready for installation. Be sure to check out our rotary alignment video to properly calibrate your system. Thanks everyone for watching. Keep an eye out for more rotary build, project, and pro tip videos soon. See you in the shop.